So this topic today, we're dealing with parabolas, as we have been doing for quite some time here. Why is that not? There we go. So a specific application is projectile motion. So something gets thrown. That's all that really means. Okay, projectile motion. You can see this is the equation of a parabola. Okay, does that parabola open up or down? What if g is negative? It opens up. So we don't know in this case. So I don't know that this opened down. It opens down if g is negative. Excuse me, opens up if g is negative. Opens down if g is positive. Okay. But this equation is, you may have seen this if you've taken a science or physics class. The height of an object is negative 1/2 gt squared. G is the force of gravity. Okay. And then gt squared plus v sub 0 t. This notation just means the initial velocity. It's just a constant, okay? That sub 0 means just initial. h0 is the initial height, okay? And so t is the time, our formula is in seconds, and then h is the height of this object, okay? So objects, can they be thrown up? Okay, can they be thrown down? Okay, so if I take this pin, if I throw it up, the velocity is positive. If I take this thing and throw it down, the velocity is negative. Okay, so that's the concept for that. What about if I have it, it's right here on the table, and it just rolls off? Okay, did I force it up or down? No. So what was the velocity? It was 0. Okay, so if I force something up, that's an initial positive velocity. If I force it down, that's a negative velocity. If it just rolls off, like a car rolls off a cliff, that's 0 initial velocity. So I'm not adding anything to it. For all of our problems, gravity is going to be represented by this constant. This will be on your test. The actual number, I'll give you this number, so you won't have to memorize it. But if the problem is using feet, gravity is 32 feet per second squared. If we're talking about meters, gravity is 9.8 meters per second squared. And then likewise, I said, if the object is moving, if I force the object up, the initial velocity is positive. If I force it down, the velocity is negative. If it's solitary or just rolls off, I don't give it any force, that's an initial velocity of 0. So let's take a look at an example. A projectile is fired vertically upward at a height of 600 feet above the ground with an initial velocity of 803 feet per second. Okay, so write a quadratic model that shows the height in seconds after the projectile was launched, okay? As many times as I can, when I've got a formula, I'm going to write that down, just like we did with parabolas. Minus 1/2 gt squared plus the initial velocity times t plus the initial height, okay? And then it's just a matter of figuring out what those values are, okay? What is gravity in this problem? It's going to be 32 because I'm talking about feet. So it's 32 feet per second squared. What is the initial velocity? 803 feet per second. What's the initial height of this object? 600 feet, okay? Okay, so if I know all of those, I know what this model is. This model is ht is negative 1/2 times 32 t squared plus 803t plus 600. And I can simplify it just a little bit. This h of t is negative 16 t squared plus 803t plus 600. Okay. So in all of these, I think it helps to draw a diagram to tell you what's going on. So where does this object start? Yeah, so at 600 feet above, it starts. Where does it go? It goes where? It goes up or down. That's what I'm looking for. It goes up, but eventually it goes down. So you guys are on top of all of that, okay? So that's what's happening. This thing starts at 600 feet, it goes up, and it goes down, okay? During what time interval would the projectile be more than 5,000 feet above the ground, okay? Where is that going to happen on my drawing here? Where's 5,000? So it's somewhere higher than 600. I mean, I think maybe it's there. It could be, I don't know, but somewhere there's 5,000. So I'm going to have to solve it to figure out. So it's possible that it's going to hit that line how many times? Twice. So that means it hits 5,000 feet on the way up and it hits 5,000 on the way down. Okay, so if I can find when that happens, I'll know the time period at which this thing is higher than 5,000 feet. So I need to figure out where this parabola and the line intersect. So what will I do? Yeah, set this equation equal to what? Equal to 5,000. Okay. So if I can figure out where that happens, where does negative 16 t squared plus 803 t plus 600 equal 5,000? Okay. I don't like any of my quadratics to be equal to 5,000. I want them to be equal to 0. So I'm going to write this as negative 16 t squared plus 803 t plus 600 minus 5,000 equals 0. That's really as far as I need to go. I mean, I could subtract. That's going to be negative 4,400. I could do that, but I really don't need to do that step because my calculator can handle it just like it is. How do you want to solve this one? Completing the square, quadratic formula, or what? Calculator. Okay, so you should be conditioned now. I'd rather use the calculator for this. So it's menu, algebra, polynomial, complex roots. So it's what? Negative 16 t squared plus 803 t. And it was either minus 4,400 or I could just write, plus 600 minus 5,000. Okay. You want the expression that's set equal to 0. And then what do I put after that? Comma t and enter. And there we go. Okay. So this tells me 6.26 and 43.93. So t is equal to 6.26 and 43.93. So what was the question? During what interval will it be more than 5,000 feet above the ground? What is that interval? Come on, guys. Yeah. So this is the 6.26. This is the 43.93. So between those seconds, it's higher than 5,000 feet. So between 6.26 and 43.93 seconds after launch, I know that this thing is higher than 5,000 feet. Okay. So your problem has words, your answer has words. This is not a thesis. I'm not grading the English, but it needs to, in words, answer what the problem was asking. Okay. How long would the projectile be in flight? So what condition will happen when this thing is no longer flying? So what is the equation modeling? Modeling the what? What does H stand for? Height. What do I know about when this thing hits the ground? The height is 0. So that's begging me to set this parabola equal to 0. Okay. So how long will it be in flight? It is in flight. It is going to be in flight until the moment that h of t is equal to 0. Okay. Because that means the height is 0. So I need to figure out negative 16 t squared plus 803 t plus 600 equals 0. I could find two numbers that multiply to negative 9,600 and add to 803, or I could do what? Calculator. That's what we're doing in every one of these problems. I can just recall that. I typed in a bunch of that stuff right there. If I could just back up and take out that 5,000, and that's what I'm after, okay? So it's negative 0.73 and 50.93. What was it? Negative 0.73 and 50.93. Now, one of those makes sense and one of those doesn't make sense. What makes sense here? Yeah, if you look at our drawing, where did we start? Did we start on the ground? No, we started 600 feet above the ground. So that negative point, whatever that number was, 6.3 or 7.3, what was it? Yeah, that negative number puts me right here. Well, my model really wasn't working there because I already started off the ground. So really the only thing that makes sense here is that 50. So I know that this is in flight for 50.93 seconds, okay? So pretty straightforward. I mean, all we're doing in this unit is I give you a parabola. I either ask you for the vertex in not so many words, or I ask you to set it equal to something and solve it, okay? And then come back with words that describe how it meets that condition. Okay, Joshua drops a rock into a well in which the water surface is 300 feet below the ground level. How long does it take the rock to hit the water surface, okay? Every one of these problems is using this equation. H of t is minus 1/2 gt squared plus the initial velocity times t plus the initial height, okay? What is my force of gravity here? .32. It's either 32 or 9.8. If it's feet, it's going to be 32. So that's 32 feet per second squared. What is my initial velocity? It's 0. Remember, my choices are I'm forcing it up with a velocity, I'm forcing it down. If I just let it roll off or if I just drop it, that initial velocity is 0. The other clue is that they're not telling me any initial velocity there. What is the initial height? So am I at the bottom of the well when we start dropping the rock? No, where am I? I'm at ground level, right? So how high am I? I mean, well, so I'm at 0, okay? The well is what? Below me, okay? So in this case, I'm right here at 0, okay? And then I'm going to drop it, and it's going to end up at negative 300, okay? So I'm dropping this rock, you know, something like this, okay? So that's sort of what's going on here. So let's figure out, so the initial height is 0. But I'm interested in when the height of that rock is what? Negative 300. Okay, I'm at ground level. I'm at height 0. I drop it and I know it falls to negative 300. So the problem I'm looking at here is when does h of t equal negative 300? Okay, so I'm going to have negative 1/2 times 32 t squared. What was that next term with initial velocity? 0. What was initial height? 0. Equal negative 300. So this tells me that what? Negative 16 t squared equal negative 300. So I could plug this in the calculator, or this one you could do on your own. Okay. This tells me that t squared is equal to 300 over 16. All right. So this tells me that t squared is what? That's 150 over 8, 75 over 4, I think. Okay. So t is going to be equal to plus or minus the square root of 75 over 4. Or you could, you could put it in the 300 over 16, doesn't matter. So let's just figure out. So the square root of, what was it, 300 divided by 16? So 4.33. So this is t equal plus or minus 4.33 seconds. Which of those makes sense? The plus sign. Okay, so it took 4.33 seconds. So 4.33 seconds for rock to hit the water. Okay. So again, all these problems should start to feel familiar. It's a parabola. You plug in values. I'm asking, when does the height or the value equal something, or when does it hit the ground, or what's its maximum height? So those are all ways of just setting it equal to 0 or finding a vertex. Okay. So look at this one, a little bit different question. A ball is thrown straight up from the ground with an initial velocity of 14 meters per second. Find the maximum height attained by the ball and the time for the ball to return to the ground. Okay, so same formula every time here. H of t minus 1/2 gt squared plus the initial velocity times t plus the initial height. What's gravity in this problem? Yeah, 9.8 meters per second squared. Okay. What is the initial velocity? Yeah. Is it 14 or negative 14? Well, which way am I going? I'm going up, it's 14. If this problem had been throwing it down, it'd be negative 14. What's the initial height? Yeah, so it says from the ground, okay? So we assume that the ground is height of 0, okay? So what is happening in this case? Let's plug everything in. This is going to be h of t is negative 1/2 9.8 t squared plus 14t plus 0. So h of t is negative 4.9 t squared plus 14t. All of these are going to be negative 4.9 or negative 16. It's negative 4.9 if it's meters, negative 16 if it's feet. So what's happening in the drawing? This, what is this? This is a rock or a ball? It's a ball. Where does the ball start? 0. What does the ball do? And then it goes down. That's what the ball does, okay? So that's what I'm modeling here. They asked me to find what? The maximum height. That means go find the vertex. All I need is the vertex of that parabola, okay? And then I will be in shape. Okay, I got a couple ways of doing this, you know. If I got my calculator, I could say, let's graph this guy. So I could say what, negative 4.9 x squared, it's always x's on your graph, plus 14x, okay? Graph is okay, but I'm missing what I want to find, right? So you just go into menu, window zoom, window settings. Let's take that y value, you know, let's just go higher. Pardon me? Menu, window settings. Okay. So if I needed to find this vertex, it's the what point of that is on my graph? It's the what? It's the height, it's the maximum value. So all you do is analyze which of these functions. Maximum. You click to the left and the right of that point, and it comes back with this. So what is the 1.43? That's what? In 1.43 seconds, I will reach my maximum height, which is 10 meters, okay? So in this case, they asked me what the maximum height was. So the maximum height is 10 meters, and it takes me, what did I say, 1.43 seconds to get there. So you could use the graph to get that information, What's the other way to find a vertex if I'm in this form? Yeah. T is equal to negative b over 2a. So I could do that, and I could just say, what is 14 divided by 2 times 4.9 and 1.43. Okay, so I get t is equal to 1.43. How do I find, that's the x value of the vertex. How do I find the y value? Plug this back in. So h of 1.43 is equal to negative 4.9 1.43 squared plus 14 times 1.43. Okay, so I can plug that in my calculator. So negative 4.9 times 1.43 squared plus 14 times 1.43 equal 9.9999, which we can call that number 10. So h is 10. So that's the maximum height. So either way to get that, yes. The graph is just control document, add a graph. Your graphs, you can't put t's or anything, it's always x's. So I'm going to have to write this as negative 4.9 x squared plus 14x, right? Okay, and that's the graph, and then you have to adjust the window to get that setting. Okay, so I think graphically finding the vertex is a little bit less work than manually doing it, okay? Because there's some arithmetic that happens in that scenario. What was the other question that it asked? How long is this thing until it hits the ground? What's special about when it hits the ground? Yeah, the height is 0. H equals 0 when this thing hits the ground. So that means take my equation and do what? Yeah, set it equal to 0. Okay. And I would just go to my calculator for this. So that's the menu, algebra, polynomial, complex roots, negative 4.9 t squared plus 14t. That's set equal to 0, so just say comma t and 0 and 2.857. So what do these numbers mean? When is it on the ground? Does it make sense that it's on the ground at 0? It started on the ground, and then it doesn't hit the ground until 2.857 seconds. So it is in flight for 2.857 seconds. Okay. So these start to just, I mean, they are word problems, but they should start to feel pretty straightforward, okay? A coin is tossed upward from a balcony that's 166 feet high with an initial velocity of 16 feet per second. During what interval of time would the coin be at least 70? So same formula. H of t is negative 1/2 gt squared plus the initial velocity plus the initial height. What is g in this problem? Yeah, 32 feet per second squared. What's the initial velocity? It's 16. Is it positive or negative? Yeah, positive because I'm going up. And what's the initial height? Is what? 166. So this formula is h of t equal minus 16 t squared plus 16t plus 166. So what is happening to this, whatever I'm throwing? Is it a ball or what is it? Object, coin, okay? Where does the coin start? Yeah, so it starts at 166, it goes up and then down, okay? So that's what's happening here. So what are they asking me for? Yeah. So when is this thing 70? So if this is 166, 70 is down here. Okay. How many answers do I expect? Yeah, I expect one answer for this one. I may get, when I solve the problem, I may get two answers, because there was this thing went down here, but it's really, there's only one time in the flight of this object that it's at 70. So again, it's how long is it above 70? Was that the question? Yeah, so it means it starts above 70, and until it hits 70, it will be above 70, okay? So I set this equation equal to 70, okay? So negative 16 t squared plus 16t plus 166 equals 70. Just set it equal to 0. And what I will do here is I'll just write it like this. 166 minus 70. I won't even go figure out what that is. I'll just go to my calculator and let it do the work. So menu, algebra. So negative 16 t squared plus 16t plus 166 minus 70 comma t. Okay. So negative 2 and 3. So what does that mean? Yeah, 3 seconds, okay? The negative 2 is over here, so I know that this thing is for 3 seconds, the coin is above 70 feet. Was that all that it asked? I could ask when does it hit the ground. Then you set the original equation equal to 0. You guys have that, okay? I think we're about ready to wrap up. Let's go to, here we go. Look on page 5 of your book. Anybody? Page 5. What do you see on page 5? Day 1. Back when you were lowly new minted Algebra 2 students. Yeah. So I told you on day 1, we looked at this problem, but we didn't have the chops to do anything about it. So we just said, okay, there's a guy that is, shooting a basket, okay? T is the time that the ball is in the air. So before I shoot the basket, how much time has gone by? 0. So what's the initial height of the ball? 6, okay? Because if t is 0, the height is 6. So on day 1, I asked you what was the initial height of the ball, and you were able to reason through that it was 6, okay? What's the approximate maximum height of the basketball? Now this one we just had to reason through. If I'm 6 feet tall with a basketball, and I'm going to a goal that is 10 feet tall, how high do you think the ball goes? Do you think it goes higher than 10? It can't go to, it would never make the basket. That's a bad answer. 50 foot, that's going to look pretty goofy, okay? So this one you sort of reasoned through it that it was 15. Now, that was sort of educated guesses. How would I figure that out now? It's find the what? Find the vertex, okay? So what was this model? It's negative 7, 16, and 6. So h of t let's find the exact maximum height. So that means I need to find the vertex. Okay, which way do I can do it manually or I can do it graphically? What do you want to do? Okay, I'm getting both choices. So to find it manually, t is negative b over 2a. This is pretty quick. So negative 16 over 2 times negative 7. So this is 16 over 14. 8 over 7. So that is 1 and 1/7. Okay. What is the approximate decimal for that? 8 divided by 7. 1.143. What does that number mean? That's the x value of the vertex. But in our problem, it's what? It's t. No, it's t. It's how long it takes for that ball to reach its maximum height. How do I find the maximum height? Plug this back in. So this is -7, 1.143 squared, plus 16, 1.143, plus 6. And I will go to my calculator all day long on this one. So -7 times 143? Was that it? Plus, what was it, 16 times 1.143 plus, what was it, 6? Okay. Equal 19.06. It's what? -7. Oh yeah, let me back up, sorry. So let's go back here. This was a -7. 15.15 or 15.143. So it tells me the height is 15.14 feet. Okay. See what we've done? On day one, you were calling it 15. And now, 4 months later, and all this money your parents have spent, and you can write 15.143. See? This is just such a wonderful, if it weren't for the football game tonight, this could be your Friday night plan, you know. But how much time until the ball hits the basket? What do I know about when it hits the basket? What is the ball doing? Well, I know that, but mathematically. Yeah, how high is it? 10. So I set this equation equal to 10, okay? So I'm going to have to figure out that, what, -7 t squared plus 16t plus 6 equal 10, or -7 t squared plus 16t plus 6 minus 10 equals 0. So I will put that in my calculator. So menu, algebra, complex roots, -7 t squared plus 16t plus 6 minus 10 comma t is 2/7 and 2. So what does that 2/7 mean? Yeah, so I'm 6 feet tall. How many times is it going to hit 10 feet? Yeah, on the way up and on the way down. Which of those is on the way down? The 2 seconds, okay? So it is 2 seconds. This thing is 2 seconds in the air, okay? Okay, that is it. So, anyway, that is it for today. So